We just covered the rules that govern all the senses. Now let's apply them to vision, the sense that takes up more of your brain than any other, the one we trust most and understand best. Vision begins with light. What enters your eye is electromagnetic energy, and two features of it become two features of your experience. The wavelength of light becomes the experience of color. Short wavelengths we see as blue, long ones as red. The intensity or amplitude becomes brightness. Color isn't out there in the world. It's your brain's interpretation of wavelength. Now trace the light's journey. It passes through the cornea and the pupil, the opening that widens and narrows to control how much light gets in, and the lens focuses it onto the back of the eye. There it lands on the retina, a layer of light-sensitive cells where transduction finally happens. The retina has two kinds of receptors. Rods are exquisitely sensitive to dim light but don't detect color. They're why you can navigate a dark room and why the world looks gray at night. Cones handle color and fine detail, but they need good light, which is why colors fade as evening falls. The signals leave the eye through the optic nerve, and right where it exits there are no receptors at all, creating a blind spot your brain seamlessly fills in, so you never notice the hole in your vision. From the eye, signals travel to the visual cortex at the very back of the brain, in the occipital lobe. And here's something remarkable. The brain doesn't process the image as a whole. Specialized cells called feature detectors respond to specific elements, edges, angles, movement, particular orientations, and the brain assembles these pieces into the seamless scene you experience. How do we see color in the first place? Two theories, both partly right. The trichromatic theory says the retina has three types of cones tuned to red, green, and blue, and all the colors we see come from combinations of those three, which is exactly how your screen works. The opponent process theory explains what happens further along. Color is also coded in opposing pairs, red versus green, blue versus yellow, which is why staring at a green image leaves a red afterimage. Vision feels effortless and instantaneous, but it's one of the brain's most staggering construction projects. Next, we turn to the sense that connects us to one another through language and music, hearing.